Hi, everyone. So this is going to be the first part of my Unit 10 summary. So I'm splitting this up into two parts because the unit really has kind of two different ideas in it, which link together, but feel very separate. So the first idea is, how would an individual go about deciding between consumption now and consumption later on? And so this first video is going to be all about how a person might make that decision. And then the second part of the unit is all about kind of banking and assets and liabilities. And there'll be a separate video that I'll make on that. So the first really important concept that comes up in this unit is a crucial concept in the world, which is money. So what do we mean by money? Well, you can see it here in the first sentence: a medium of exchange, and it says consisting of banknotes and bank deposits, or anything else that can be used to purchase goods and services. And then this is the really key part, and is accepted as payment because others can use it for the same purpose. So that's kind of the essential thing that makes something money, that if I use it to kind of pay someone for some good, they can then take what I've given them and use it to pay somebody else for something, for some other good or service. That's the crucial thing that makes something money, that it has this particular property. And then below it talks about the idea of barter, which is more problematic because then you have to have this sort of double coincidence of wants. That the thing that you want to trade is something I want, and the thing that I want to trade is something you want. Whereas money gets rid of the need for all of that because it's a thing that everybody agrees we can exchange goods and services for. So next kind of important idea is the difference between wealth and income. Now, we can think of income as a flow concept, meaning it is an amount of money that's coming in over a given period of time, whereas wealth is something we typically think of as a stock concept, that we kind of freeze a particular moment in time. Think about, right, at this particular moment in time, if I sold all of my assets, if I took all of the assets that I have, my house, my car, my stocks and shares, if I right now at this moment in time sold them all, how much income would that bring me? And that's what we mean by wealth. And there's this nice analogy, this like bathtub analogy, which helps to, I think, kind of cement this like picture. And so this idea that the water that's in the bathtub at any given moment in time is our wealth. And there is, water flowing out of the bathtub, out of the bottom, if we haven't put the plug in. And that's because we are spending some of that money that we have to consume, to our expenditure. But then you've got the shower head that is kind of carrying on adding water in over time. And that's going to add to our stock of wealth. But that kind of flow, that flow of water coming in, that's why we kind of think of it as income. And then we have this interesting part, the depreciation. So this is just the idea that actually some of our assets, take like a car, for example, that over time, they will actually lose their value. And as a result, that can mean that the stock of wealth decreases because of assets losing value. So this is like a really nice analogy, a nice way of thinking about the differences between income and wealth, and kind of really importantly, keeping in mind the difference between income being a flow, an amount over a given period of time, whereas wealth is where we want to think of an amount at a particular instant in time, a stock concept. Okay, so that then brings us to the kind of big idea in the first part of Unit 10, which is, what does someone do if they know that at a particular period in time, and in this case, it's going to be what we are going to label as later, if this in this later period of time is when their income is going to arrive. So we've got this character, Julia, and we are going to say that her endowment, which just means sort of this income, this amount of money that's going to come to her, is going to come later, and it's going to be $100 worth. But Julia kind of faces a bit of a dilemma because she can't wait until later to just kind of spend all of this $100, to consume everything later on. she would also maybe like to consume something now. And that is where she then faces this decision. She has the option open to her of borrowing some money, right? Of borrowing to consume now. And what I'm going to assume to begin with is that if she's going to borrow money, the interest she's going to have to pay on that money is 10% of whatever she borrows. And I'm going to write down a kind of really, really important equation that links together the repayment she's going to have to make with the amount she borrows originally, which is called the principal, and the interest, the amount she's going to have to pay as a result of interest accumulating on the principal. So if I write capital R as the repayment, and that's got to be equal to capital P, the principal, plus then capital P, the principal, multiplied by little r, the interest rate. And this can then be rewritten a little bit more neatly as the repayment is equal to take P, the principal, out as a common factor, and you get 1 plus r. Now, that r in here, in our case, is 10%, so I want to convert it into a decimal. So in our case here, it would be 0.1. So this is going to be really, it's kind of a really useful equation for determining the outcome of different choices that Julie's going to make. Julia is going to make. So let's take a kind of an extreme example, right? Which is, what if Julia decided that she actually wanted to consume as much as possible right now? So what value would that come to? Like, I mean, it says down here, based on the graph, 91. Well, where does that come from? So let's do a little bit of math to show where this number has come from. So if Julia decides she wants to consume the maximum possible amount right now, what we need to consider is, well, what's her repayment going to be? So we know that in the future, she's going to get an endowment of $100, which means her maximum repayment is $100. So let me put that into the left-hand side here. So the repayment is going to be $100. And the principal, that's what we want to know. That's what we want to figure out, because that tells us how much she's going to be able to borrow right now and then consume it. And then that's going to be, so the maximum repayment is 100. We want to know the principal, and we know the interest rate. So it's 1 plus 0.1. And a really simple bit of math here is going to tell us that then the principal, the amount that she could borrow if she has $100 to repay, the maximum amount, is going to be equal to, I think it comes out to about 90.9 recurring. So it's like approximately $91. And that's where that's coming from. And we could do a similar thing for other points along this feasible frontier, right? Feasible frontier, it's showing us all the different possible combinations that Julia can have of consumption now and consumption later on. So let's imagine that instead of this extreme case where Julia kind of sacrifices all of her consumption later on to get as much consumption now, let's take a kind of maybe a more realistic case where Julia decides she wants to consume $67 worth of consumption. She wants to have that much consumption later on. So what is that going to mean? I mean, again, if we look at the graph, we kind of can see that that translates into her having $30 of consumption now. So let's just do the math to make sure we're clear on that. Okay, so if she consumes $67 later on, then that means, well, how much is she going to have left to make a repayment? Well, she's going to get 100 later on. If she wants to keep 67 of that to consume, that means her repayment, the maximum repayment she can make, is going to be $33, right? The difference between that endowment that's going to come later on and how much she wants to consume later on. And so that again has to be equal to the principal, how much she can borrow then, times 1.01. And again, quick bit of like rearranging, we can see that the principal here would be 30. That's how much she could borrow and therefore how much she could consume right now. And so we could, do similar things for all the different possible values of consumption later on, and therefore all the possible repayments she can make later on. and figure out how much consumption you can have right now. And that's essentially how we construct this feasible frontier, how we figure out all the different possible combinations of consumption now and consumption later that Julia can have. So maybe the final thing to mention about this graph is that feasible frontiers is something we've seen before in lots of previous units. And we know a very key thing about feasible frontiers is their slope, because their slope, which we also have referred to as the MRT, the marginal rate of transformation, that's supposed to tell us about what is possible in terms of transforming one good or service into another, right? We saw this with consumption in free time and like various things throughout the course so far. So one really important thing I want to point out is actually that the slope of this feasible frontier, the marginal rate of transformation, is going to be equal to 1 plus R, 1 plus the interest rate. So just to touch on briefly why that is, well, remember that the marginal rate of transformation is supposed to tell us kind of about a trade-off, right? Like what is the kind of trade-off between one thing, one good and another good. Now the trade-off here is going to be between consumption later on and consumption now. So if we kind of think, well, if Julia wanted to get, say she's got 0 consumption right now, and she wants to get $1 of consumption right now. Well, what's that going to mean? Well, it's going to mean she is going to have to sacrifice $1.10 later on, right? Because if she borrows $1, then she's going to have to pay that back. And how much is she going to have to pay back if she borrows $1? Well, based on an interest rate of 10%, if she borrows $1, if the principal is $1, multiply that by 1 plus, in this case, 0.1, and that tells us her repayment is going to have to be $1.10. So there we get this sense of like what the sacrifice is, right? To get $1 of consumption now, she has to sacrifice $1.10 of consumption later on so that she can make the repayment. And that is why the slope of this is 1 plus R, because the 1 plus R tells us what is the trade-off, right? $1 extra of consumption now, sacrifice $1.10 later on. If she wanted $2 extra of consumption now, she'd actually have to sacrifice, so 2 times 1 plus R, she'd have to sacrifice $2.20 of consumption later on. And so that's like a really, really crucial link for this model, that the slope of the feasible frontier, the marginal rate of transformation, which tells us about the trade-off that has to be made. In this case, it's just 1 plus the interest rate. Okay, so that's like one big side of this model, which is, what is possible when a person can borrow. The other big side of the model is, well, what does the person actually want, right? So why are they borrowing? It's in order to achieve a higher level of utility, or to put it differently, to get to the highest possible indifference curve. And what we're going to see shortly is that we can treat this model of sort of borrowing in exactly the same way that we've treated previous models, where what the individual will do is choose a level of consumption now and later on that gets them to the highest possible indifference curve. But before we kind of get to that part, let's think about, well, what are the indifference curves in this particular model telling us, and why do they maybe have a particular shape? And so we are going to assume that the Julia's indifference curves look like this. Okay, so kind of like steep in the middle. Sorry, I didn't mean steep in the middle. So as we get towards the kind of further to the left and further to the right, you can see further to the right getting very, very shallow, further to the left getting very, very steep. And that is to reflect a kind of psychological reality that we sort of assume about people, which is that if you offer people kind of different bundles of consumption now and consumption later on, that they'd much prefer to have a smooth level of consumption, right? Consistent consumption now and later on, pretty similar amounts, that actually people would be less likely to be happy having these extreme bundles, right? And the shape of this indifference curve kind of shows us that. And I mean, another way of referring to it as this willingness to smooth consumption is because people have diminishing marginal returns to consumption. That when, let's kind of look at this section over here, consumption now, if I have, like, say, this really high level of consumption now, right? And you offer me a little bit more consumption now, even when I'm at this really high level, then I'd actually want to, let me just pause for 1 second here, just to make sure I'm explaining this clearly. So I'll just pause for one. All right. So apologies for the little pause there. I just wanted to make sure I get this explanation right. So again, let's imagine that we've got an individual who is over here, is given like this like allocation, quite a lot of consumption now, not much later on. Well, where the smoothing element comes in is they would be quite willing, you can see, to kind of get up to this middle point. They'd be quite willing to actually sacrifice quite a lot of consumption now, like to sacrifice quite a lot of what they have now to actually achieve like a smaller increase later on, right? So that kind of shows us that willingness to actually try and get things to be kind of balanced, smoother between now and later on. That the shallowness here shows us they'd be willing to sacrifice a lot of consumption now to get like a little bit later on. And when we're over here, say like at this extreme where it's a very, very steep, that's kind of corresponding to maybe not having so much consumption right now. And what we see, why is this getting steeper? Well, what this is showing us is if a person has not that much consumption now, and you say to them, okay, I want you to reduce it even further, in their mind, for them to be indifferent, they would then actually, so to reduce their consumption now a little bit, they would actually need a big increase in consumption later on to convince them to do that. And so it's like, take both of these together, what it's indicating, the shape of this indifference curve is indicating, is that a person would be kind of happier in this middle ground where they're getting a kind of similar level of consumption now and later on. And again, that's kind of something that we think seems pretty reasonable, that if you look at people's behavior in general, that's kind of what they tend to do. They tend to smooth their consumption. So that's one reason for the shape of these indifference curves. There is a second thing we need to consider, which is it's not just the shape of these indifference curves, this kind of willingness to maybe have have these extremes. It can also tie into something called pure impatience, right? Which is not about consumption smoothing, but this pure impatience tells us about a person's willingness or desire to have consumption now over later on. And there's two reasons we kind of think of for why that might be the case. One is myopia, and what we mean by that is short-sightedness, that maybe people don't appreciate the importance of consumption later on, or of kind of getting something later on, and therefore they put much more value on the here and now because they just don't think about the future so much. Or we've got this idea of prudence, and what we mean by that is someone might actually think, well, what if I'm not around later on? Then that's pointless to kind of save this amount for later on, to kind of have this ability to consume later on, because I might not be there, so I'm better off just consuming right now. And one way we can kind of see this pure impatience on one of these indifference curves is if we kind of consider these two situations. So like point A, this seems to be, the perfect consumption smoothing, where consumption now is 50, consumption later on is 50, so same today and tomorrow. And we can see that this person is indifferent between being there and being at this point B. Now, the interesting thing about point B is there's a reduction in consumption now of 1, but in order to convince this person to reduce their consumption now by 1, we have to give them 1.5 later on. So because they value now more, in order to convince them to take a cut right now, we have to offer them an increase tomorrow that's bigger than the cut right now. And that's a perfect example of this idea of pure impatience, because what it's showing us is the value that someone's putting on consumption today is higher than their value of consumption tomorrow. And that's another reason for the shape of these indifference curves. So the overall shape kind of is a consequence of these two things: the desire to smooth consumption because of diminishing marginal returns to consumption, and also an element of pure impatience. And these things are captured by what we refer to as a person's discount rate. And okay, the really, really key thing that we're going to link together now the discount rate with the indifference curves, and then another third really important variable, which is MRS, the marginal rate of substitution. So we've seen this a lot before. The marginal rate of substitution is the slope of the indifference curves. And we are going to say that the MRS in this case is going to be 1 plus rho, 1 plus the discount rate. And right, where is this coming from? Well, I can't give too deep an explanation, but we basically say that a person's discount rate, it's the slope of their indifference curve minus 1, right? And we know the slope of the indifference curve is the MRS. So MRS minus 1 gives you the discount rate. And the idea is it's telling us the willingness, the strength of the person's desire to substitute consumption now for later on. That's what this row is supposed to capture. And you can see this discount rate depends on the two things that I was talking about before. One is this desire to smooth consumption. So like, how strong is that desire? And the second is the level of pure impatience. Like, how much value does a person put on today versus tomorrow? So these two things will then kind of inform what the value of a person's discount rate is. And then because we define the discount rate as the slope of the indifference curve minus 1, we can then get this nice formula that the marginal rate of substitution, therefore, is 1 plus the discount rate. So what that's going to allow us to do then is kind of now put all of this together. We've got our indifference curves, we've got our feasible frontier, and as with lots of the models we've seen before, when it comes to the person making a choice and making the optimum choice, well, what are they going to do? So in Julia's case, she has the option of all of these points along the feasible frontier, right? Now, she also has the option of all the points below it, but it wouldn't make sense to pick any of those points when, you know, she can be on the feasible frontier. So Julia has to choose a point along the feasible frontier, and she's going to choose the point that allows her to achieve her highest possible indifference curve. And the highest possible indifference curve is going to be the indifference curve that is a tangent to the feasible frontier. And so that's going to be at point E. And as we've seen so many times before, that is where the marginal rate of substitution equals the marginal rate of transformation. But interestingly here, what that means is Julia will choose the point where the marginal rate of substitution, 1 plus her discount rate, is equal to the marginal rate of transformation, which remember is 1 plus the interest rate. And so a little simple bit of math tells us that the point that Julia will choose is the point where her personal discount rate, right, is equal to the interest rate. And remember that her personal discount rate, it's the slope of the indifference curve, but the slope of the indifference curve changes as we move along the indifference curve. And so Julia is going to choose an allocation where her personal discount rate is the same as the interest rate. And that should make perfect sense, because if we think about what these things are telling us, so her personal discount rate, that is her personal desire to trade off consumption now and consumption later. And the interest rate is what is the actual ability to do that. And so it makes perfect sense that a person would choose the place where their willingness to trade off between consumption now and later on is equal to their ability to trade off between consumption now and later on. Good. So that is how a person in this model will make a choice of where they want to be along this feasible frontier. Now, there's, I think, one more other big element to this first half of the unit, which is, so far we've had Julia, who gets her endowment, her income later on, and therefore she's got limited choices, right? In fact, she's really only got one. She can borrow in order to fund consumption now. The second big thing is, well, what if we now have a situation where the person, and now we're going to have Marco, where this person actually has their endowment now. So we see down here, Marco's endowment, he gets his endowment of $100 right now. And that opens up a whole realm of different possibilities. And you can actually see that from the fact that there are 4 different feasible frontiers drawn on this graph for Marco. And so let's just kind of walk through the different things that Marco has open to him as a result of having his endowment right now. Well, the first one, this kind of shallowest feasible frontier, this is actually where the only thing that Marco can do with his endowment, and his endowment is coming in the form of grain, and the only thing he can do with it is store it. And actually, this seems like a really, really bad option, because if he stores it, we've got this story about like mice eating it, and he'll actually lose 20% of what he stores, which is why you can see his initial 100, if he decides to store it, then and he decides to store all of it, then later on he'd only have 80 left. So actually, this doesn't seem like very good. But if that was his only option, then you can see he would choose point H here, because that is the point that gets him to the highest possible indifference curve, and where he consumes 68 now and then has 26 for later on. But as in, well, to be more realistic, Marco's going to have more options open to him. So the next possible option is where Marco could actually lend out some of his initial endowment and lend it out at a rate of 10% interest. So whatever he lends out, he's going to get 10% back on top of that. And again, to take the kind of extreme scenario to help us see this nice and clearly. So if Marco decided to lend out all $100 right now, well, what would that mean? It would mean that later on, he would get back 110, right? 100 he's loaned out at a rate of 10% interest. So he's going to get his original 100 back plus 10% of 100 plus 10. And so he'll be able to consume 110 later on. And obviously, he can kind of do different amounts in between that, right? He could decide to consume, some of the initial 100 and lend out the rest. And again, well, what's he actually going to do based on these indifference curves? He's going to choose, I think, if I'm looking at this right, point J, where actually he consumes 65 now and then 39 later on. And then we open up an even more like generous option for him, which is if instead of lending out some of his endowment, he actually invests some of it, and we see there's a 50% return. So this is really, really similar to the previous case. All that's different is now that instead of getting $1.50 back for every dollar that he, instead of getting $1.10 back for every $1 he lent out, in this case, he's going to get $1.50 back for every dollar he invests. And using that same reasoning, if we look at this new feasible frontier, we can see if Marco did the extreme case of basically investing all 100 of his endowment, then later on he'd get 150 back and could consume 150. And again, all these choices in between. And what's he going to do? Well, based on the indifference curves, he's going to choose point K, where he gets consumption of 60 now and 60 later on. And then we come to the kind of final possibility, and this is the most interesting one, because this is the one where he has open to him that same investment with a 50% return. But interestingly, he also has the ability to now borrow, right? And this is kind of all these options open up because of having endowment, right? Having an endowment right now, you've got so many, having the money right now means you've got so many different options available. And why this is interesting is you can see that actually this is going to mean, this ability to borrow now is going to mean that even though Marco's endowment is only 100 right now, if he wanted to, he could actually achieve consumption now of around 136. So let's actually kind of see like how that could be possible. Well, if Marco decides to take his endowment of 100 and invest it all, right, we know that that's going to mean later on he is going to get $150 back on that investment. And if Marco knows that, he's kind of thinking, well, if I know the maximum amount that I'm going to have later on is 150, let's go back to this formula that I used earlier on. The repayment equals the principal times 1 plus R. So we know the maximum possible repayment Marco could make is 150, because if he invests all of his 100 that he gets right now at a 50% return, he's going to get $150 worth back. So his maximum repayment will be 150. And then equal to the principal, how much is he going to be able to borrow? And then multiply by 1 plus. And now the R here is the rate at which he's borrowing, which is 10%, so 0.1. And a quick calculation, I'm just going to do it really quickly on my calculator, will show us that the principal, therefore, the amount that Marco could borrow if he's able to repay 150 later on is 136.36 recurring. And so that shows us where this comes from. And like overall, what are we seeing here is that when someone has the money right now, generally their options are much better, right? They have so many more things that they could do with it. And that allows them then to achieve much higher levels of utility. And we can see that when Marco has this set of options where he can invest and borrow, and he's on this feasible frontier, this kind of dashed one, we can see that he's able to actually achieve and get to point L, where consumption now is 80 and later on is 62. And if you compare all of the 4 different bundles that you can kind of go through that you see on the graph, we see that L is the highest indifference curve. And why is that? Because if you add up the consumption now and later on for all these 4 possibilities, you'll see that the highest total is this one at L. So that pretty much brings me to an end for this first part before I go on to the banking. Aside from just a quick little summary, which is these options that Marco had open: borrowing, lending, storing, investing. The key with all of these things, or what are they allowing someone to do, is to move consumption through time, right? You can see with Marco, he's got this $100 to start off with, and having all these options open, being able to lend or store it or invest it, or having borrowing available too, means that it's possible to now take that $100 you start with and make so many different possible choices. Have lots of different levels of consumption now, lots of different levels in the future, allows you lots of choice. And why do we want that? Well, coming back to one of the big reasons, because smoothing consumption allows for a higher level of utility, because we assume that people have a bit of impatience, not because they have a bit of impatience. So people will want to do this in order to smooth their consumption, because we know that utility is higher if consumption is smoother, or because they have pure impatience and therefore would prefer to have more consumption now. But these activities also allow people to actually have higher consumption in both periods. And we saw that in Marco's example. It gets the highest possible amount by investing and then doing some borrowing. And a very important point to end on, if we think about what we saw with Julie, Julia, what we saw with Julia and what we saw with Marco, that actually what they're able to do depends very much on their circumstances. Now, I didn't point this out before, but Julia and Marco have the exact same indifference curves. And the only thing that like causes the difference in what they're able to achieve is their initial circumstances. Marco had the $100 right now, so a whole range of options. Julia only gets the $100 later on, and so is restricted in terms of her options. And so actually differences in people's situation can have a big impact here, as we saw. And then the other big thing that's going to have an impact is, well, what are people's levels of pure impatience, and potentially also like what about their desire to smooth consumption? How strong is that? So that's the end of this kind of first part of the Unit 10 summary. In the second part, I'll talk about the banking side of things, and I'll try and also kind of tie the two of these things together.